So today we start the 2D transformation, which is called two-dimensional transformation. So what is 2D transformation? First, in the real world, we frequently rearrange objects or look at them from different angles. So the effect which is desired, which include the changing the size of an object or its position, or changing the size, or changing the orientation of an object, rotation of an object, changing the size, or changing the, you can say that reflection of an object. So all these things include the implementation of such a change is called a transformation. What do you mean by transformation? What the meaning of this word? Transformation means change. So in this chapter, what we will discuss these things in the 2D. The first is transformation, second is rotation, third is scaling, fourth one is shearing and reflection. First we will discuss the concept of this, then we implement this with the help of numericals. So let's start from the first one, which is called transformation. Or translation. Sarva maine galat kiya. Translation. It's not transformation, it's translation, which is in 2D. What is translation? Translation means changing the position of an object. Suppose this is x-axis, this is y-axis. Suppose this is an object. It has any position x and y here. It has some value, x-axis value and y-axis value. Suppose we have to move at another location. The location is x dash and y dash. So the movement of this object from this position to the new position x dash and y dash is known as a translation, right? Like for example, suppose x dash and y dash are the new position of an object. X and y are the old position of an object. Clear? So how much we translate from here to here? So here tx and ty are known as translation coordinates. Clear? So what will be the formula? So x dash is equal to x plus tx and y dash is equal to y plus ty. What is it? It means x dash is the new translation position, which is x plus tx. Tx is the translation coordinate. Y dash is equal to y. Y was the old position in y-axis, plus ty is the new translation coordinate. So in matrices form, it can be written as x dash y dash xy plus tx and ty. Is it clear? Or after that we will discuss 2D rotation, then we will move afterwards homogeneous coordinates. Is it clear? Okay, so next topic is 2D rotation. Rotation means you are rotating of an object. It can be a clockwise rotation or it can be a anti-clockwise rotation, like moving or rotating of an object at a particular angle. We have to rotate an object at a particular angle. Clear? So first we have to derive an equation of rotation in 2D. So here first we have to discuss what is a 2D rotation. Suppose here you can see it is the radius r, it is the radius r. Suppose here P is an object. It is the old position. Now we have to rotate an object anti-clockwise. So P dash, x dash and y dash is the new position after the anti-clockwise rotation at a specific angle. P is a old position which is making an angle phi, and the distance is x dash. Clear? And here P dash, x dash, y dash is making an angle theta, and the position is, that is called x. Clear? So here can we write x is equal to r cos phi and y is equal to r sin phi? Here x is the old position which is making an angle phi. So can I write x is equal to r cos phi, y is equal to r sin phi, which is the first equation. Clear? So here can I write like here x dash which is making the combination of two angles theta and phi. So here x dash is equal to r cos of theta plus phi, and y dash is equal to r sin of theta plus phi. This is the second equation. So what we have to derive here, we have to derive the anti-clockwise rotation, that is called anti-clockwise, like this. Here anti-clockwise rotation which is at a new position P dash which is making an angle theta. So we have to find out the whole equation in terms of angle theta. We have to remove the angle phi which was the old position. Clear? So here can I write like this cos A plus B, that is cos A cos B minus sin A sin B, that is cos A cos B minus sin A sin B. Similarly here sin A plus B is sin A cos B plus cos A sin B. So here sin A cos B plus cos A sin B. Clear? So after opening this bracket, r cos theta cos phi minus r sin theta sin phi, r sin theta sin phi. Similarly from here r sin theta cos phi, r sin theta cos phi plus r cos theta sin phi, cos theta sin phi. Now here this whole equation, that is x dash and y dash, which is the new position after the rotation, is in the term of the angle theta at an angle phi. But we have to convert this whole equation in terms of angle theta, because after rotation it making an angle theta. So what will we do? From the equation 1, can we convert this? Yes. From the equation 1, if we see in the equation 1, r cos theta is equal to x. So can I write like this from equation number 1, what? R cos theta is equal to x. So r cos phi. Can I write here r cos phi is equal to x? Clear? So x dash is equal to here r cos phi, which is equal to x. So can I write x cos theta plus, can I write from equation 1 r sin phi is equal to y. So here r sin phi is equal to y. So it's minus y sin theta. Clear? Similarly for y dash, can I write here r cos phi is equal to x. So can I write here x sin theta. Similarly plus, can I write r sin phi here, r sin phi is equal to y. So r sin phi is y, which is y cos theta. So if we look these two equations are in the term of an angle theta. So what we have done? We have done the conversion of an angle phi in the angle theta. Why we have done? Because after the rotation, the new position making an angle theta, not the angle phi. Clear? So this is the new equation number 3, which is the anti-clockwise rotation, because this is called anti-clockwise position. So how we will write this equation in the matrices form? So in matrices form, we can write like this: x dash y dash, which is equal to here cos theta minus sin theta here. Clear? Cos theta, it's cos theta minus sin theta. सॉरी कट करना पड़ेगा आपको, वो क्लॉकवाइज का था, वो एंटी क्लॉकवाइज का था. It's I am deriving in the anti-clockwise. It's cos theta, it's minus sin theta. Here sin theta and cos theta, clear, or x and y. So this is the equation or matrices in anti-clockwise, clear. Similarly, when you convert, suppose you derive in the clockwise rotation, what will be the change? What will be the change in the matrices? Suppose there is a question comes in the exam, you have to rotate an object in anti-clockwise, then you have used this equation. If the question comes, you have to convert an object or rotate an object by clockwise rotation. What will be the change in clockwise or anti-clockwise rotation? This is a matrices of anti-clockwise. And what will be the matrices in clockwise rotation? I am writing here x dash y dash is equal to, what will be the change? There is a change in the sign here, that is called cos theta, sin theta, minus sin theta, cos theta, and x and y. This is the equation in clockwise. Clear? So note down these two equations. This is anti-clockwise and this is clockwise. So this is called 2D rotation. Okay, the next topic is 2D scaling. 2D scaling. Scaling means what? Scaling means changing the shape or size of an object, that is called a scaling. Means suppose there is a spring. When you press the spring, the shape is changing. Suppose there is a rubber band. When you extend that, the shape is changing. So it means the scale in or scale out the size of an object. You are changing the size of an object, that is called a scaling. So in 2D scaling, what is it? Here, suppose there is an object. Suppose there is an object. Clear? It has a position x and y. When you extend that an object, the position can be large, or when you compress that object, this can be a position, that is called scale in and scale out position. So here x dash and y dash are known as the new shape, the new change in the size of an object. So here, what is it? Sx and Sy. Sx and Sy are known as the scaling coordinates. How much scaling is done on the x-axis and y-axis. So here, what will be the formula? X dash, which is a new scaling coordinate in x-axis, which is x into Sx, and similarly y dash is equal to y into Sy. So in matrices form it is written as x dash y dash, Sx Sy, xy. In 2 by 2 matrices it is written as Sx 0, 0 and Sy. Clear? So moving to the next topic, the next is called shearing. Okay, the next topic is shearing. Shearing in 2D. What is shearing? So shearing is similar, not we can say that similar like a scaling, but some bit how. Like in scaling, what we have done, in scaling changing in the size of an object, but in shearing distortion in the shape of an object. What do you mean by distortion? Distortion means the changing or the shape of an object in terms of an x-axis or in terms of an y-axis. So we will discuss what is x shearing and what is y shearing with the help of a diagrams. So what is do you mean by distortion in the shape? In distortion means the opposite and parallel layers of an object are simply slided with each other. So the shape of an object is changing, but the opposite and parallel layers are slided with each other. So what do you mean by this? Here, suppose we are talking about x shear. What is x shear? In x shear, there is no change in x-axis position of an object, but there is a change in y-axis position. Here, sorry, what is in x shearing? I'm repeating again. What is x shearing? X shearing means there is no change in y-axis position. There is a no change in y-axis position, but there is a change in x-axis position. Here, suppose this is an object. The value, this is, you can say that it's a rectangle. The 4 coordinates are 0, 0, 1, 0, 1, 1 and 0, 1. So the x shear is in this direction. Clear? So the opposite and parallel layers are simply slided with each other. Clear? So here what will be the matrices? X dash and y dash are the new coordinates after shear. XY was the old position of the object. So here I am talking about what is X shear. There is a no change in Y axis. So here suppose in this matrices, this is a matrices of X shear, this one. Here this is called X axis position and this is called Y axis position. So there this is X axis, suppose this is Y axis. So there is no change in Y axis position, but this is the change in, this is called X shear. This is a change in X axis position, right? So similarly, same like X shear, I am talking about Y shear. Y shear means there is no change in X axis position, but there is change in Y axis position. Here suppose it is an object, it has some values. Clear? In Y shear, the shear direction in this opposite direction. So the opposite and parallel layers are simply slided with each other. So X dash or Y dash are the new position of an object, XY was the old position of an object. So here suppose this is an X axis and this is Y axis. So there is a no change in X axis, but there is a change in Y axis. Clear hai? So that is called Y shear. Clear? So that's all about shearing in 2D. So now the next topic is reflection in 2D. Reflection in 2D. Clear? Refraction means mirror image of an object. Clear? It's simple. Reflection means the image, reflected image, or you can say that mirror image of an object. But here we will discuss 5 different types of reflection. The first one is called reflection about x-axis. These are very simple terms. Reflection about x-axis. What do you mean by reflection about x-axis? Suppose here x-axis and y-axis. Suppose our object is here. So what will be the reflected image? This is called reflection of this image. That is called reflection about x-axis. So what will be the matrices after reflection? In x-axis reflection, here what will be the matrices? The matrices will be like this. Clear? How we write this matrices? What is x-axis reflection? Suppose in x-axis reflection, suppose it is x-axis and it is y-axis. So simply matrices we write like this. Clear? This is a general equation of a matrices. But in reflection about x-axis, when we find out the reflection about x-axis, there is a no change in x-axis, but there is a change in y-axis. Suppose if we are talking about this example, it has some x value positive, y value positive. The reflected image is here. It has a x value positive, similarly x value positive, but y is negative here. So similarly y is negative here. Clear? So in x-axis reflection, there is a no change in x-axis, but there is a change in y-axis, which is the value negative. Clear? So the next is reflection about y-axis. Second is reflection about y-axis. So what do you mean by reflection about y-axis? It's simple. Suppose our object is this. Y-axis reflection will be here. So here, this will be the reflected image. So what will be the output? What will be the matrices here? Here x is positive, y is positive. Here what will be the y is negative, y is positive, but x is negative. So the matrices is this. What is this? Suppose this is x, this is y, this is whole x, this is whole y. So in y axis matrices, there is a no change in y axis, but there is a change in x axis. Similarly, third is reflection about origin. What is this? Suppose it is an origin, this is an object, the reflected image will be here like this. This is the reflection. So here suppose x is positive, y is positive, but here x is negative and similarly y is negative. So what will be the matrices? X dash y dash is equal to x, there is a change in x, similarly there is a change in y. Change in x, change in y. X is negative, y is negative. That is called reflection about the origin. Clear? I am talking about the fourth topic, that is called reflection about straight line. Here. The fourth is called reflection about straight line. What do you mean by straight line? Suppose this is like this. Suppose this is a line which is passing through the origin. Clear? So suppose the object is here, so its reflected image will be here. This is the reflected image. It has x-axis positive, y-axis positive. Similarly, reflected image also x-axis positive, y-axis positive, but there is a exchange the values of x-axis and y-axis. So what will be the matrices? The matrices will be like this. It's 1 0. Clear? What is this? In simple matrices there is 1 0 0 1, but there is a x value will be y, y value will be x. That is called reflection about straight line. So that's all about the reflection about 2D. Okay. Next.